Let us see application of dot product in physics. This is the displacement vector and this is the force. Now they are not in the same direction. Angle between displacement vector and force is theta. Here it is lesser than 90. Here 90 degree. Angle between the displacement vector and force is 90 degree. Here more than 90 degree. Work is the dot product of force and displacement vector. Then as per definition, dot product is modulus of F vector, modulus of displacement vector, then cos theta, where theta is the angle between displacement vector and force. Modulus of F vector, so you can write F, modulus of D vector, that is displacement vector, D, modulus is D, then cos theta. W is equal to FD cos theta. Here theta is less than 90 degree, so value will, cos theta will be positive, so work done is positive. Here 90 degree, cos 90, 0, so work done will be 0, in this case positive. Here more than 90, then cos theta will be negative, so work done can be negative. Now let us see one example. A particle is acted upon by two forces, F1 vector, 2i cap plus 5j cap plus 6k cap, and one more force. This particle is acted upon by two forces, F1 and F2. F2 vector is minus I, minus 2j, minus k cap. Then because of the forces, the particle is displacement from the position 4, minus 3, minus 2 to another position whose coordinate is 6, 1, minus 3. Let this be A and this be P. So this is the displacement vector, AB vector. Now net force is F1 vector plus F2 vector. You have to add these two. So 2i minus I, that is I, then 5j minus 2j, that is 3j, then 6k minus k, that is 5k. So this is the net force. Then displacement vector is AB vector. So AB vector, let O be the origin, then AB vector can be written as position vector of B minus position vector of A. So OB minus OA. So OB, that is 6i plus j minus 3k minus OA, this position vector of this, that is 4i minus 3j minus 2k. So use to subtract these two vectors. So AB vector, that is displacement vector. Now 6i minus 4i, that is 2i, then plus j, minus into minus plus, so plus 3j and this j, it is 4j. Next minus 3k, here minus into minus plus, so minus 3 plus 2k, that is minus k. Then work is defined as the dot product of force and displacement. So take the dot product of force and displacement. So force is I plus 3j plus 5k dot displacement vector. Displacement vector is 2i plus 4j minus k. When you take the dot product, you have to multiply the corresponding components. I dot I is 1. So 1 into 2, 2. Then I dot j will be 0 because the angle between I and j is 90. Now the corresponding component you have to multiply. 3 into 4, 12. J dot j is 1. So 3 into 4, 12. Next 5 into minus 1. So minus 5. So 2 plus 12, 14, 14 minus 5 is 9. See, work is a scalar quantity. You are getting a number. So work is the dot product of force and displacement. Work is a scalar quantity. One more example. A particle is acted upon by two forces. F1 vector 3i minus 2j plus 2k. F2 vector is equal to 2i plus j cap minus k cap. Then because of the forces, the particle is displaced from the position 1, 3, minus 1 to the position 4, minus 1, lambda. Let this be A and this be B. Then work is the dot product of force and displacement. In this question, work done is given to be 16 units. You have to get lambda, value of lambda. Work is the dot product of force and displacement. Force is the sum of these two, net force. 3i plus 2i, so 5i, minus 2j plus j, so it is minus j, then plus 2k cap minus k cap, so it is 1k cap. So this is a net force. Then displacement vector. Displacement vector is AB, that is displacement vector. So that is AB vector. So AB vector, that is position vector of B minus position vector of A, that is 4i minus 1i, so that is 3i, then minus j minus 3j, so it is minus 4j, then lambda k minus 1k, so this is lambda plus 1k cap. Then you have to take the dot product, but work is given to be 16. So when you take the dot product, you have to multiply the corresponding components. 5 into 3, 15, minus 1 into minus 4, so minus into minus plus, so it is plus 4. Then here 1, here lambda plus 1, so lambda plus 1 into 1 is lambda plus 1. Work is given to be 16 units. Then 15 plus 4 19, 19 plus 1 20, so lambda plus 20 is equal to 16. Take this 20 to the other side, so lambda is equal to 16 minus 20, so it is minus 4. Value of lambda is minus 4. If the work done is 16 units, the value of the lambda is minus 4. Thank you for watching.